everyone, today in this lecture we will be seeing about OpenGL and how we will be working with 3D graphical primitives using OpenGL. So first, let's go on to what is OpenGL. So OpenGL is actually a cross-language, cross-platform application programming interface, basically an API for rendering 2D and 3D vector graphics, and it is used to interact with a graphics processing unit to achieve hardware accelerated. Here we are showing an image. OpenGL, the design. This API is defined as a set of functions which may be called by the client program. Although functions are very similar to C language, it is language independent. You can use it in different languages like C++, etc. And then development, it's an API, evolving API, and so Kronos is the group which is releasing it, but there are additional vendors who also change a bit of the API and reproduce in their form like we do in Linux. And then the associated libraries. So the earliest version is released with a companion library called OpenGL Utility Library, but then it's a quite complex. We have something like glue, and so implementation we can do it in different platforms. Mesa 3D is an open source implementation of OpenGL, but there are other platforms also which make use of this API. So here in this presentation we will be doing further programming, and that will be using the Glute library also. So first let us know what is Glute. So it's basically a utility toolkit which is that is independent toolkit for writing OpenGL programs, and it implements a simple windowing application programming interface for OpenGL. It's easier to learn and explore. That are some of its advantages. Now further, if you tell how can we like install Glute will be dealt in the further in a few minutes. So now let's see other things like Glute, like GLU, GLX and DRI. So GLX is used in Unix, and it's used on Unix OpenGL implementation to manage interaction with X Windows system and to encode OpenGL onto the X protocol stream for remote rendering. And whereas GLU is the OpenGL utility library, and this is a set of functions to create texture maps from a base image, map coordinates between screen and object space, and draw quadric surfaces and NURBS. DRI is the direct rendering infrastructure for coordinating the Linux kernel, X Windows system, 3D graphics hardware, and an OpenGL based rendering engine. So further, now coming on to 3D primitives in OpenGL. OpenGL uses primitives to draw all vector primitives like points, lines, polygons, rectangles, etc. You can do both 2D and 3D, but for 3D primitives we have to call the projection function, which is called GL ortho. So all functions for drawing primitives start with GL begin, as like in programming we have main and everything. So here the syntax is GL begin, and we give the primitive name, and we have to end it with GL end. So it's like basically what you do for the graph, where you close the graph, open the graph, the same thing. And then void GL vertex, so that like here in the given program what we are going to do is we are going to have a cube or a pyramid. So for that, this GL vertex 3F is a very common function which we are going to use further. So I have given two examples of how the GL vertex function, like the function works. So here in GL vertex 3F, 1.0F, 1.0F, 0.0F, it's basically the X, Y and Z values. So 1, 1, 0, it shows the upright corner. It's like the basic in the Cohen-Sutherland algorithm. It's not similar to this, but kind of we can interrelate that and tell about this. So it's the upper right corner, then it will be 1, 1, 0. Now if it's a lower one, there we had like 4 coordinates. Here instead of showing the upper lower distinction, we are using the minus sign. So the lower left corner will be -1, -1, 0F. Now further, these are some of the images of the OpenGL primitives. So GL points are these one, like V0, V1, V2, all the vertexes. The lines are by joining these vertexes, and the strip is by joining all those. After drawing all the lines, you join again all the lines. And a loop means the starting and ending point. If you connect it, like you start from V0 and you end in V0, then it becomes a loop. Now if it's a polygon, it's quite similar to a loop. And then triangles is like three-sided, a loop with 3 sides. And then triangle strip means a continuous triangle pattern. Fan, it all depends on how you rotate the angles. And then quads are there, quad strips are there. So we will further see all these things. Now if you are creating a pyramid and a cube, what you have to do is you already create a triangle, and that triangle you're going to convert to a pyramid by adding a left side, back side, right side, the top and bottom, or for converting a square into a cube. Then we'll blend the colors of the pyramid and the cube so that we can see the difference of how the 2D is like converted to a 3D part. So that's all about the presentation. Now we'll see the coding part. So for the coding part, what you have to do is, first you have to have code blocks. You could use anything, but code blocks is definitely much easier to implement Glute. So what is here is, first what you have to do is, you have to install code blocks. That can be done easily by going to Google Chrome. Now just go on to codeblocks. The website is codeblocks.org, and here in downloads option, you just have to click on the download option, and then you can download the binary lilies, which I have done. And you can just set, the setup which you have to use is Mink W setup exe, because it has the, here they have given the node part, and there they have mentioned that it includes a GCC, G++ compiler and debugger and things which are required for our, because we are doing the C++. Sometimes the setup exe might not work, so it's better, it's a safer option to use the Mink setup exe. So now further, after downloading code blocks, the next step is the Glute library. So the Glute libraries can be downloaded from the Google Code Archive. So here you just have to go to the following website, like the link code.google.com/archive/p raw video player/downloads. In that you come across the Glute 3.7.6 bin.zip file. You just have to download the zip file and unzip it, and you have to further change some of the folders onto the code block thing. So further, how we'll start a project is the project option. You go to the project option. So you go on to this option here, right here. You go and press on the project option. So here are a number of things which we already actually download. So there are so many things in which you have to go to the Glute project, because we are going to use OpenGL. You can also use the GLFW, but here we are going to do with the Glute thing. So you press on the go option again. Now it will come. You just do some changes and stuff. So you can give the project title. Now here I'll give as lesson 1. Now the folder to create, you can create the D drive. Yeah, so I have already a folder opened here. So what you have, you will create a no lessons. I'll create a no one lessons. So yeah, okay. Now come 1 second. You go to volunteer lessons and you press OK. Now it gets saved. All those files get saved here. Now you have to select the Glute location. The Glute location is the one where you had already included. They have already informed that this folder must contain the subfolders include and lib. So in mine, I have kept it in the from step 1. It will be like Windows C, where you have saved it. It will be in program files X, is probably for everyone. Code blocks. Go to min.gw. Go to include option. So the include option said that there will be a GL option. So actually we'll have those first 3 files already while you are installing the code blocks. These 2 files are the file which you had already downloaded from the Google thing. So you have to copy paste Glute as well as Glute library into the min.gw, and then into library also what you have to do is you have to have the Glute to show. I'll show. Yeah, so the Glute library you have to paste it here. As well as these are the 3 steps. Like first step is like in the include one, second is in the library one. Now the third one where you have to go is you have to go to Windows in the C, and in that you have to paste another Glute. Glute.dl should be pasted. See, I have already pasted it. It's not already there. You have to paste it. This is required because in the first section of the code, while I'll be showing you the code, we add this part. So it's very important that you do that. So here so this is a path which you require. So you copy this path, you paste this path, and you press next. So you get a window. If everything, all those 3 files are properly kept, then you will get this window, which is like the starting window. Now the compiler, you just have to do all the default options. Now you get a new one. So here I already had a demo one which had other things, so lesson one. Now this main.cp is a thing which is like a default file which is already imported and compiled and everything when you do all the first few steps. Now if you run this program, they'll ask to build, so you just give yes and you get this. You get all these shapes which are like already inbuilt. Some the thing is, some kind of codes are running on the background, due to which you get all these images. And so first let's say demo program. So in this particular program, what we are doing is we are having the window size. We are drawing a circle. So it's not a 3D thing, it is just through 2D type. Just to get an idea of what the glute is and everything, it's better you do a simple program in the beginning. So we have like two functions here, void init and void display, as well as the main function. Other than that, we have two functions. So this create window circle drawing, this will give name to the window. Like when I'm running this program, what I get here is, now we just have to close this so that it works properly. So the first function include stdio.h, then glute is for including the glute.h file which are already included in the file, and then math.h because we have to perform some cos and sine functions, and the pi value we are just defining it so it will be easier for us in the future. So first, to initialize, we are using my init function. You can give like it doesn't matter, you can give any name. Now color, in this part we are giving the background color, clear color, that we are giving the background color as black in the beginning. Now then for the color of the circle, we are giving as 0, 0.0, 1.0, 0.0. This follows the RGB values. And then the next part is the breadth of the picture boundary, which we are giving as 1 pixel, and then the projection GL matrix mode as GL projection, and then we are load the identity, and then we are setting the window dimension in the XY direction using the ortho 2D. So now next part, for displaying, first we are clearing the window, and as we had mentioned before itself, when we start some like primitive, we have to start with GL begin, and the primitive here we are using its point, so we are giving points, and then float x and y, that is like for the circle part, x, y and I. So first what we are doing is we are iterating y up to 2 into pi times, that is 360 degree for the whole circle, the small increment angle, and for that we are using this for loop. So I equal to 0, I less than 2 into pi, and I plus equal to 0.001. So each time we know the formula as x is equal to r into cos I and y is equal to 2 like r into sin I, where r is 200, and we are doing the vertex part like GL vertex 2i x comma y. Then we'll ending since we have completed with the primitives, we'll do the end function as we had already explained in the PPT, and then we are flushing it out. In the main function, we are doing the initializing part, glute init, and then display mode we are initializing, we are giving the window sizes, and then we are naming the window. The window naming, it actually comes on the upper part, upper left corner. We'll get the title as circle drawing, and we are calling the initialize function as well as the display function and the main loop. So let's once run the program and see. So we are pressing, like first we have to build it, so just go here, build file. Now after that we just have to go to the build option and run. So here we are going, this is the part which I told as circle drawing. Since this is the black background we have given, it's coming like black, and this is the RGB we are given green, so the circle is coming in the form of a green circle. Now let's go on to the next part. This is for the 2D graph. 3D part with the pyramid and the cube. Let's take the program first. It's already written here. So 3D. Now what you have to do is we have to add it onto the, we have to right click it, add file to the active project, press like it's all this thing, just remove this demo so that it doesn't make any confusion. You should build it. The build is not going to, just save it once, and you have to close this tab so that the build option is visible because the compiler is running now. Now give it right click, press the build file. Now so first let's go on, and then right click on this, press the build file option. Now press on the build option, run option. So here we can see that the triangle is converted into pyramid with different colors, and you have a cube with like you can see the two faces of the cube. Now if you go on to the code, this is the windows.h. This is a portion why we have included the glute file in the Windows option in C, and then the include gl/glute. Now the title we have given as 3D shapes. Now this is the initializing part where you get the background to black and opaque, and then you give the depth test, smooth shading, and now load identity is to reset the model view matrix, and this is the part is of utmost importance, like color 3f and vertex shift. Color is to specify the color, as well as the vertex 3f, it shows where should you draw the vertex, like should it be in the upper part, lower part. So negative denotes low, and if it's positive it denotes upper, and then right left. That is what it shows all about. So this part is for the cube part. With 6 chords we are drawing the cube, and in the triangle we have a pyramid which consists of 4 triangles. So you go with the front, right, left and back parts. And then for reshaping, like if somehow the height is equal to 0, then you have to prevent the modulus by like you should not divide by 0, so you should change it to height equal to 1. And then you have to, in case like if you don't, the window size ratio is not proper, then you have to change the ratio, that is what is did on the GL matrix mode, and load the identity. And further, the main function where you initialize everything, you call the initialize function and the main loop for drawing the images. Further, we can draw a lot of different kinds of images. We can add animations to it, as well as you can change the colors and other effects. So that's all with this video. So here the video's main objective was to know what is OpenGL, and we have seen that it is an API, whereas we have just got an introduction into glute, and we have created a pyramid and a cube using the help of code blocks, OpenGL and also glute, and we have also seen how to create a 2D using a circle. So that's all, and thank you.